higher off the ground, it wouldn't have that sort of interference. But yeah,
Yeah, so the laser beam, um, you can sort of think of it in space as taking up kind of the space of a tube in the simplest case, right? Of like you've got the laser beam and then the laser comes out of it. Um, so if it's physically and it does fan out, right? But if it's physically above the ground, it's not going to it's not going to wiggle into the ground. It's going to stick within the size of the path, the
yeah,
thickness of it that you shot it out from until it gets very far and then widens out.
that makes sense. Yeah. So
Yeah,
in
so you should
theory,
be
we could
good
even
keeping it, yeah, even just a slight distance off the ground.
yeah. Thank you. So in an orthographic view, I think we could probably draw lines. They won't be parallel. I guess they would diverge from the laser to the other point, right? I guess they wouldn't be exactly parallel, but we could maybe draw physical lines to represent the laser diameter expanding.
Mm? Yeah, yeah. Yeah, the further back, you sort of put something that receives the laser beam, the bigger the dot, the point of impact of the laser beam against whatever the target is.
Exactly. Yeah. So that was the diagram the last diagram I was hoping to show, but I'll have to work on that maybe in the morning. It's getting late. But yeah, thank you for looking at
I don't
them.
mean to keep you up, but what are you trying to do with this?
Oh, in theory, maybe find a way to accurately or hyper accurately show this in an infographic showing how uh, it could work on the flat earth and the globe. Maybe have like a hyper graphic for the globe version with earth curve in the diagram infographic orthographic view, and then a planar orthographic view, and
Right.
just show how that would, like, those beams would appear just
Mhm.
for fun.
Right. So the idea, if you got it very level to the ground or very level to the water at one point, and shot it forward, does the water on the other side, is it higher above the water than where you shined it out from? Has the water level curved down below
Exactly.
while it went straight forward? Yeah.
Yeah.
Yeah, I mean, it's a very
I
good test to
wonder.
do.
Oh, but the only thing is, I guess the laser potentially could also bend in
It
the
can.
pressure
That's the
group.
difficulty that
Ah,
people.
yes,
It's very hard to isolate out all these variables. Uh,
absolutely. I wonder if we go to mountain peaks with these sort of lasers. People must have done this, but I guess it's elevation, finding the exact two elevation points and verifying the elevations, and but yeah, what a challenge, hey? It's easy. Science.
well, yeah, it is. I guess to offer a general comment, I notice how often the conversations end up getting bogged down in these topics of things that really have to do with the atmosphere, the refractory effects of light going through different layers of the atmosphere with different humidity and temperature. And like sort of one of the issues I see coming up a lot is that something interesting to me that the flat earth community has identified is that the modern scientific understanding of how complicated optics is offers enough complexity to almost always allow for the possibility, maybe not the probability, but the sort of the technical possibility of sort of wildly different explanations or shapes to what you're looking at that are being distorted through kind of long range bending of light. And I could say that I think that um, measurements of what the refractive index of the air over the Earth are trustworthy enough to say that the experiments that have already been done on this are pretty conclusive that the Earth is curving. But I don't act. I mean, I don't. I do think that, but I don't know that because I'm not an atmospheric scientist myself. And so I'm taking seriously the idea of, okay, let's not trust any institutions. Let's reset back to the beginning and only put any sort of stake in sort of what we can directly test. And these are a lot of variables. Like this is really hard to do of properly controlling for all the possible things that could be causing a beam of light to um, potentially bend or warp in some way that makes it very ambiguous how to interpret what it is that you're looking at, what the data actually says.
So true. Well put. Excuse me. Well put.
All of which is to say that Flat Earth community definitely has an interest in topics in science that are very complicated and very difficult, and yeah, definitely.
And fun to kind
I
of
mean, I would just like to see
figure out.
more citizen scientists attempting these things, regardless of what their motivations are. I think that it is a strictly good thing for more independent individuals to practice and disseminate how to go out into the world and try to take very difficult measurements of the landscape and the path of light and things like that.
Oh, absolutely. I think it would be fabulous. This is what I'm working on, but if anyone wants to collab or if you do it yourself, all the best. I would probably buy the book. I'd love to see a book made. Do you know the infographics I'm generating, basically?
Mhm.
Something even far superior, but essentially the same thing, where we take a steel man and then we create a hyper accurate uh, visualization, whether orthographic or any sort of whatever's required, and then we put them next to the same stillman of the globe, where and then we can, because let's say if it's obviously a globe, at least we can hear or see a visual of what flat Earth is trying to represent, and then show, look, this is what they say. This is the stillman of the flat Earth position, and then here's where they go wrong. You know what I mean? Because now we can compare.
It is that the possible answers, of course, are uh, yes, no, or no, of like maybe we'll figure this out at some point, or maybe it's just not solvable. I mean, it's always possible that there are perfectly legitimate seeming questions in math, like are there an infinite number of twin prime pairs? And in a sense, there is no yes or no answer. That like just there's actually no way of proving it one way or the other, and you can't check every number because there's infinite numbers. So it may
Yeah,
just be impossible to know, or maybe someone will figure it out. And it's like maybe someone figures it out, and maybe no one ever figures it out because it's impossible to figure out. And I don't know the idea.
that's
When I was little, you would assume like, oh well, it's just you keep working at something in math, and eventually you get to a yes/no answer, a true/false answer. But no, not everything has an answer. It's very possible to look at a pattern in math and ask this very reasonable question of, does it go on forever? Does it stop? And therefore, just literally be no possible way of knowing.
yes. Just fun to think about, even just because it's it's a challenge to even find it.
It gives me a lot of respect for the unknowns, for the limits of human knowledge.
For sure, for sure. We were joking the other day, ZZ. You weren't here about. Do you know how we have? Bull Knight was helping us with this. So we went from milli to million and billion to trillion, and eventually there's going to be a range that maybe hasn't been labeled yet because maybe the guy retired. But we were joking around naming it like Flatillion or Flat Earth is fun, billion.
I think there's a lot of numbers have been named already very high up.
Yes,
We're not at any risk yet in any kind of human context for getting up into numbers so big we haven't come up with names for them yet. But
that's true. But just for fun, you know what I mean? That would be hilarious. Get it into the dictionary or the math textbook. We can call one globillion. for the globe and homage to the globe. But yeah, prime numbers. Wow, math is amazing. Oh, you were saying? Sorry.
I was just gonna say that there's a lot of debate about like is math something created or discovered, and I sort of think of math in the way I think of like the game of chess, in the sense that like chess is something that at a literal level humans made up to be a toy version of real ideas we were seeing in the world, kings and generals and the army soldiers, in the sense that like chess is something that at a
We can call one globillion for the globe and homage to the globe. But yeah, prime numbers. Wow, math is amazing. Oh, you were saying? Sorry.
I was just gonna say that there's a lot of debate about like is math something created or discovered, and I sort of think of math in the way I think of like the game of chess, in the sense that like chess is something that at a literal level humans made up. It was meant to represent something. Like it was meant to be relevant though to the world. It was meant to be a toy version of real ideas we were seeing in the world, kings and generals and the army soldiers and stuff like that. So it was meant to be like a little toy recreation of ideas in the world. And like we made up the pieces. We made up the rules, like we definitely made up that part. But we then got to discover what was possible within it. Like nobody made up certain winning moves. Like that was a legitimate discovery. So when humans first came up with the pieces of chess and the base rules of chess, they might have been making that part up, but they didn't know what that could lead to. So I guess I sort of think of math in a similar way, of like the base elements of something is kind of something we made up, but it's based on something. It's meant to be representative of the real world, we think, but then we don't know what the consequences are of playing with these pieces and how complicated they can become as they interact together. Like we decided at some point that it made sense to start counting things one, two, three. That's probably a pretty natural and obvious way to look at the world, but it still was a choice on our part to decide that like counting things was a sensible way of thinking about the world. It might seem like such an obvious choice, it's hard to even imagine not doing it, but like at one
Yep.
point it was a choice in a brain. But we didn't make up the idea of prime numbers. Like we did then later discovered that of like, oh wait a minute, some of these numbers
Mm.
are special. They are different, and yeah, and so I kind of have this like sort of I don't know in between view.
That's a good
Uh,
analogy. Yeah.
yeah, that thinking about something like a game of chess where we got to make up the pieces, but we didn't get to make up what an actual winning strategy would be. We had to discover that as kind of having some compromise between is math discovered or is math invented, because I do
Mm-hmm.
wonder, as hard as it is to imagine, of could it have been possible to make a very 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 different starting rule somewhere very core within mathematics and then kind of
Mm.
play out what the consequences of that would have been. And it's sort of hard to imagine what that would be, um,
There, at
because it
that
because it
point.
seems so natural to say 2 plus 2 is 4. We're thinking about, 2 apples, and 2 apples is a collection of 4 apples. But I don't know. What if we lived in a universe where when you bumped 2 apples together, they created a third? Then it might be much more natural in that universe for the concept of math to have started at the level of, sort of 1 plus 1 equals 3, right? It's like, we picked a couple core rules for math because they seemed reasonable for the way we observed collecting groups of objects together in the real world. And it is, but it's still interesting to contemplate, what if we had made the starting rules for math different? What if we lived in a universe that was very different from the one we live in today, where it would have made more sense to think about these things in very different terms than we do? And
Yes.
yeah, I don't know. I hope people find that
Like I just.
interesting.
Abs- I'm so sorry. Yeah,
No,
absolutely.
no, please go on. Yeah.
you know, it just came to mind through my imagination. You're saying 1 + 1 =
Yeah,
3. I was just thinking in the real world. Okay, let's say you have a male pollinating tree with a
yeah, you
female
can use
pollinating.
reproductive. Yeah,
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 and then now we have
with
three.
a baby.
So
I mean,
the
it
one
doesn't work
plus
with
one
inanimate
equals three.
objects, right? Yeah, so
It's
we sort of we think of that as the special case, and it doesn't work for inanimate objects. But I don't know if the laws of physics were such that every time you bumped two identical objects into each other, they created another one, then we would totally be trained to think in terms of 1 + 1 = 3 in such a universe. That's just not
in a
the
weird way.
universe we imagine living.
Yeah,
Yeah,
interesting. But yeah, imagine. Oh man, the history of math is fascinating too. I watched a few videos on the history of math, like where it goes back to ancient Egypt and Babylonia, how they started counting. Pretty fascinating.
yeah. When you go very far into math, it gets into this really weird territory where the questions become sort of so big and so complicated that they're actually unanswerable by the standard rules of math. So now you're at a fork in the road where you basically have to say, okay, the standard rules of math couldn't answer for me this question I had. So if I were to add a new rule into math, what would I want that to be? And this gets into things in set theory and thinking about infinities and stuff like that. But there's sort of a sense to which, people got to ideas of infinity and realized that the basic rules of like addition and multiplication and counting and stuff were just insufficient, just not up to the task of handling um, dealing with infinities that people now wanted to think about and deal with. So they had to now go sit down and decide, okay, like in this version of math I'm creating here, what do I want the rules to be for how infinities of various kinds are supposed to behave? Because the base rules of math aren't giving me any guidance here anymore.
Yeah. Oh, for sure. Do you think there's more math to be discovered? So we had like
Yep.
calculus,
I
different.
think it's literally endless. I think it's literally open-ended. This is the
Wow.
implication of something that's called the incompleteness theorem. And basically what the incompleteness theorem says is that no matter how you set up your base starting set of rules for a system of math or a system of logic, you'll eventually get to a question that seems like a perfectly coherent question to ask, that it doesn't have a yes or no answer, that the system itself can't handle. And then at that point, if you want to go any further, you have to add something to your system of rules.
Mm,
Uh, like for example, like the question is when you like, and I think infinity is an interesting example here. Is infinity plus one bigger than infinity? Um, this like the standard rules of math for non-infinite numbers don't give you a clear answer as to how you're supposed to think about that. So what people do is they come up with their own concepts of infinity. Like there's a well-defined concept of infinity in which adding one to it doesn't change it. It's still just infinity. But then other people were like, you know what, I want a different version of infinity, a different rule set, like kind
yeah.
of a different code for how to deal with infinity, where we do track the difference between infinity and
Mm,
infinity plus one and infinity plus two. So what people discovered was that instead of there being one right answer, we're kind of just open. Sort of math was incomplete, and where you're sort of open to go off and explore which version of math you would like to explore, like to decide. It's
makes
still about
sense.
the idea of you set out some rules and then you follow those rules through to their consequences. But in a sense, like you're free, to decide what the rules you think should be for infinity are for the concept of infinity, and then you get to play out what the consequences of those rules are and explore it further. And it's in a sense, it's sort of like it's not like one is more right than the other. It's more that just like people have come up with these different entities, these different
Yeah.
sort of animals of infinity that are not exactly equivalent to each other, because they're kind of programmed with different rules for how they're supposed to work. And it gets really weird. There's all different schools of thought and especially with infinity, really big debates between mathematicians about should we be using the concept, should we be rejecting the concept, which version of it should we be using for what purposes. It kind of just seems like it sprawls out forever and ever and ever. Of yeah, that there's no endpoint to it. There's no endpoint to sort of the game of playing with math.
Interesting. Yeah, yeah, absolutely. I think that's a great analogy. I was just looking up here. There's no Nobel Prize for mathematics. It's a
I
separate
didn't know playing with
prize called.
fields.
Yeah, I didn't know that. I was just wondering who's going to be getting the next Nobel Prize in math. But it looks like there's another prize called the Abel Prize
Oh yeah.
or
Uh,
Abel.
Let me write something out here. This is one of my absolute favorite um, things. Um,
Exciting.
okay, I just wrote something out. I just posted it. Just take a quick look. Tell me what you
Yeah,
see.
yeah. So doubling.
Right, it's the doubling pattern. Right, it's adding one plus twice one plus. It's just adding all the numbers together that where each is a double to the last.
Okay.
So by any kind of normal way of talking about this, you would look at this and say, that's infinity. It never stops getting bigger. You're adding ever bigger and bigger and bigger and bigger numbers to each other. So what else could it possibly be other than infinity? And there's a sense to which that's true. But there's another sense to which there's actually a way to rearrange it. See, there's something interesting that's going on in the doubling. It's kind of like every number knows about its next nearest neighbor because it's not a random pattern, right? It's not a
Hmm.
random set of numbers you're adding together. It's a very specific sequence. And there is a way to kind of realign the sequence, kind of add it and subtract it to itself, where suddenly down the chain everything starts canceling out. And surprisingly, the one thing that's left over is -1. So there's this claim that some people make that 1 plus 2 plus 4 plus 8 plus 16 plus 32, on and on and on forever, instead of being infinity, is only -1. And at that point,
Really?
you have to kind of make a choice of, do you accept what they did as legitimate? Because to get there, and I could show you how to get there, it is technically using the normal rules of addition and subtraction, but it's using them on an infinitely long sequence of numbers. So if you just reject that it's legitimate to do this to an infinitely long sequence of numbers, then you would say that the result is nonsense. But if you're comfortable with the idea of imagining doing an infinite number of additions and subtractions to kind of rearrange and recombine all the things within these series, you do get out -1 as the last piece that survives, the last piece that remains. Um, so I show it to people, and sometimes they'll be like, well, is this true? And my question to them is typically like, well, do you want it to be true, right? Do you want to accept the series of things I did to get to that result as legitimate? In which case, if you do, then we're stuck with this end result that's really surprising. Or do you want to say, actually, for some reason, it's illegitimate to add and subtract numbers in the way you're doing so, when you would have to kind of do so an infinite number of times to get this end result, because you were never meant to be able to add and subtract things an infinite number of times in the first place. And I honestly, both positions are valid. They're just kind of different perspectives on the topic. But if you want to see how to actually do the manipulation as to like, what am I talking about here? What is this rearrangement that gets us there? I'll just type it out right now, real quick.
Yeah, yeah.
If you're
That'd be
interested.
amazing. Thank you.
Yeah.
Interesting. I didn't really enjoy math as much as I should have in high school.
I would say
But
it's taught in a really bad, sucky way, in my opinion. It's unfortunate
yeah,
because I feel
yeah,
like there could be things within it that are made much more interesting. But um, like you'll see, like stuff like this is not. There's a lot of things that like with very not even very complicated operations you have to do. You can get to some very surprising results. Um, so I'll have that written up in just a sec.
Yeah, thank you. Take your time. And shout out to Geo. Thank you. And all you lovely people out there.
So feel free to ask
Nice.
any question about anything that's happening at any step. All right. So step one, I have the sequence, and that all I'm doing is I'm just naming it X. Just giving it a name. We're just going to call it X. That's the whole thing. And step two, all I do is put the one off on its side and just group together everything else. Haven't changed anything. The parentheses don't really add anything. I'm just saying like it's one plus and then the rest of it. The critical thing, pull a two out from the rest of it, right? Because two is two times one, and four is two times two, and eight is two times four. So what I'm noticing here is that the whole rest of the sequence after one is 2 multiplied by a copy of the whole sequence. So I get to x equals 1 plus 2x. Like this sequence of 1 plus 2 plus 4 plus 8 plus 16 does have this property that it's 1 plus and everything that comes after that is an identical copy of the sequence multiplied by 2. So this line is just a true fact that the sequence is 1 plus 2 of itself. But then you see what I do at the end there. Subtract over the 2x,
Yeah.
get negative x equals 1, so x is negative 1, right? So the fact that the sequence has the property that it's equal to 1 followed by 2 multiplied by the same sequence itself would, by any normal use of math, mean that this thing is negative 1. And yet, it also is 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64, on and on and on forever. I don't know if it means it's equal to negative 1, but it seems to hold some sort of property in common with negative 1, such that every single move I've done here is legal. Like every single move here I've done here is legal, other than perhaps the objection that you were never supposed to do x minus 2x anyway, because they were both infinity. But on a strict line by line basis, there's no illegal maneuver, according to math.
Interesting. Well done, ZZ.
It's very fun. There's a lot of things like this, and it's really hotly debated across math and physics of whether or not we should consider it legal to do these things, to convert things that look like they're obviously infinite into things that are not.
Hmm. Negative numbers are pretty fascinating. Some people say they don't even exist, but no, in math, I mean, it's there.
I mean, I think it's pretty easy. Like debt, right? It's negative money. You could
Yeah,
be poorer than $0. You could have debt.
yeah. It's not going anywhere. Negative
Yeah,
numbers are a
not.
real thing, I think.
Yeah. Yeah, that's a perfect example of it, right? If you're in debt, then you have to get money to be at zero money. So you're in the
Yeah.
negative.
Maybe it's like, oh yeah, the math is just fascinating. It's incredible. I have a good math joke that I heard from